So we have defined the bonding as the chemical combination of elements to form a compound. The other question was, you give the characteristics or properties of, they were physical properties. Eh? They were physical properties of compounds that are formed by ionic bonding. One of the properties that I told you when I was teaching, I told you to write those properties down, but some of you did not listen to me, and that's why you failed them. You didn't know what to say. Hmm? So I am warning you this time, those who don't hand in my assignment, I'm going to remove you from my Google Classroom. If you don't hand in today, that will be the end of me and you. I remove you, and I change the password. You know what you will go through to be added again. So stop that bad habit of not handing in. So the question was, give the physical properties or characteristics of compounds that are formed by ionic bonding. I had asked for 4. And by the way, I can ask for differences. What the property that I give you for compounds formed by ionic bonding should be the opposite of the compounds formed by covalent bonding. You get that? So if for ionic bonding I say they have high melting and boiling points, that means the property of compounds formed by covalent bonding will be they have low melting and boiling points. That will be the corresponding property of compounds formed by covalent bonding. If I say that for ionic bonding, the compound formed conducts electricity in aqueous or molten state. Let me explain this. When I say the compound conducts electricity in aqueous state, it means when the compound formed is dissolved in water. That's when it will conduct electricity. In molten state, I mean if it is a solid and is heated to melt, then we say it is now in molten state. So molten state is the state in which a solid has been heated to become a what? A liquid. That's what we mean by molten state. So if we are saying for ionic compounds they conduct electricity, then the corresponding one for covalent compounds we should say they don't conduct what? Electricity. If we are saying that compounds formed by ionic bonding are soluble in water, compounds formed by ionic bonding are soluble in water, then it means that compounds that are formed by covalent bonding are insoluble in water. Now, many of you are giving only 3 and you failed to get the 4th one. So the 4th one, I'm adding it for you. It is here. Compounds formed by ionic bonding. Many of you are saying they are hard and brittle. I closed one eye and gave you that mark, but that's not correct. Don't write that again. The other property should be they are crystalline solids at room temperature. All compounds that are formed by ionic bonding, sodium chloride, sodium oxide, calcium oxide, magnesium oxide, all of them, they are crystalline solids at room temperature. Crystalline solids at room temperature, I mean that room temperature means that temperature where you have not cooled and where you have not heated. So they are crystalline solids at room temperature. So that means for covalent bonding, as we shall see, for them they will be liquids or gases at room temperature. So those were the properties that I wanted. And you people, again, we still have a challenge. I still have a challenge with many of you. Formation of these compounds, you are going to study it until senior 4. I don't know why you cannot get some time and learn how to draw these diagrams properly and correctly to show how compounds are formed. The first question was asking you to show how magnesium chloride can be formed. Now, magnesium chloride is a compound formed between magnesium and chlorine. The electronic configuration of magnesium is 2 to 8 to 2. Remember, this time I had said use only the outermost energy levels. Although in our notes they had used all the energy levels with the electrons. The question says use the outermost energy levels. Then pick the outermost shell, the very last shell outside. It should be the one that you do what? That you use. So for magnesium, the electronic configuration is 2 to 8 to 2. Meaning it has 2 electrons in the outermost energy level or outermost shell. Then chlorine, its electronic configuration is 2 to 8 to 7. What does this tell us? This tells us that magnesium has got 2 electrons to lose to become stable. So when magnesium loses these 2 electrons, it will remain with the inner shell containing 8 electrons. And that inner shell, we say it is stable. It will be stable because it will now contain 8 electrons when magnesium loses these 2 electrons. But you have to keep in mind that when an atom loses electrons, it gets a positive charge. And the atom that gains electrons gets a negative charge. So for chlorine, its electronic configuration is 2 to 8 to 7 because the atomic number of chlorine is 17. So it means one chlorine atom has got to gain 1 electron in order for it to have 8 electrons in the outermost what? Shell. So that's why we must draw another atom of chlorine because each chlorine atom must gain only 1 electron. But magnesium has got to lose 2. So the other electron must also be lost and it should be gained by another chlorine what? Atom. Now the other mistake you have been making, when this electron is lost, then it should go to the electron that has not been paired. When you are writing these electrons, I told you, you begin with north, then you go to south, then you go to east, then you go to west, then come back to north, then come to south, east, and finally west. That's why I have 1 electron on the west part because it has nothing to pair. For them to be 7, it remains unpaired. So, and again, I told you when this electron is transferred, the arrow only shows that the electron is being moved from magnesium to chlorine. But don't put the electron immediately. If you put the electron immediately, then it will appear like the electron was there originally, and then you are moving another one there. And when you move another one there, the atom will have 9 electrons, yet the maximum is what? 8. Hmm? So after all that process, when magnesium loses the 2 electrons, it will have a positive charge, and there will be no shell because the shell has been containing 2 electrons and all of them have been lost. Eh? So we have magnesium with 2 positive charges. The charges are put on the top right corner. Top right corner, that's where we put the charges. Eh? So we have magnesium with the 2 positive charges. And then now the chlorine atoms are 2. That's why we put these 2, show that the chlorine atoms are 2. And each chlorine atom has gained 1 electron. So it will now have 8 in the outermost shell. So that's why these ones are now what? 8. And when they are 8, we shall put a negative charge to show that this atom of chlorine, which originally had 7, gained an electron, which is negatively charged. So when an electron is gained, it comes with a negative charge. That's why there is always a negative charge on the top right corner. Note, we put the negative charge on the top right corner. So you have 1 minute. Can anyone ask a question on this part where you are not understanding? You people, you are not going to avoid this work, I assure you. So the earlier you understand it and practice it, the better. And I want to thank Shadrach. Shadrach has always passed this work very well. Whenever I give assignment on bonding, he's accurate, no mistake. So anyone having a question on that? I think then it means silence means no. So calcium oxide, the valence of, the atomic number of calcium, I forgot to put a 2. The atomic number of calcium is 20, so the electronic configuration should be 2 to 8 to 8 to 2. So there are 2 electrons in the outermost shell. That means calcium has to lose 2 electrons. Then the atomic number of oxygen is 8, and the electronic configuration is 2 to 6, meaning oxygen has 6 electrons in the outermost shell. We begin with north, south, east, west, north, south, and that's the electronic structure of oxygen. That's the electronic structure of oxygen. I forgot to put a 2 and the O inside this to show that it is oxygen, but it is still okay. So that means oxygen must gain 2 electrons and calcium has to lose 2. So that one is the simplest. Calcium loses 2 electrons, it gets 2 positive charges. Then oxygen gains 2 electrons. The electrons that have been gained are here, where they are being represented by E. Those are electrons that have been gained, so that the maximum, the total becomes 8. And since 2 electrons have been gained and each electron is negatively charged, we put 2 negative charges on the top right corner. And finally, 2 positive charges, 2 negative charges, the overall becomes 0 charge, and the compound formed is calcium oxide. Very simple work. I enjoy this work so much. Sodium oxide. The atomic number of sodium is 11. And the electronic configuration is 2 to 8 to 1. So that means sodium has only one electron to lose, but oxygen needs to gain two. Always look at this. If sodium has only one electron, and the atom to which it is losing two needs two electrons, then you must draw another atom of sodium. The sodium atoms must be two, such that each one of them contributes an electron, such that the other atom gains all the two. And finally, that will give us two sodium atoms, whereby each one of them has gained one electron. Now, most people put here two positive charges. That is wrong, because each sodium atom has lost only one electron. So you cannot put two positive charges. Yes, and oxygen has gained two, so it should have two negative charges. Finally, two positive charges, two positive charges, two negative charges, and the formula is sodium oxide with two sodium atoms and one oxygen atom. So the commonest mistake that you are making was that you don't know where to put the charges. The charges are put on the top right corner. So two negative charges, this is where we put it. So that was it for the corrections of the work I had given you. Anyone with a question, I repeat you people, and I emphasize this work is very important. Any question? Any question? So that means you have given me a green light. I can now proceed with our work. I think our work was on page, it was immediately after sorts. It was immediately after sorts. I remember telling you to read there. Yes, here we are. We have finished ionic bonding, and we have looked in details at how these compounds are formed. Please don't disappoint me again by failing this work again. So let's now focus on covalent bonding. You have the notes. Covalent bonding is on page 116. So you already have some ideas, some knowledge that covalent bonding is a type of bond that is formed between two atoms where all the atoms are non-metals. So covalent bonding, we are saying this is the type of bonding that occurs between non-metal elements. Yes, this is the type of bonding that occurs between non-metal elements to form a compound. This one is not new to you. Covalent bonding involves mutual sharing of electrons. So in covalent bonding, there is no transfer of electrons, but there is sharing of electrons between the elements, and the elements are usually non-metals. So the elements involved, they must contribute an equal number of electrons to the formation of the bond. The elements involved contribute an equal number of electrons to the formation of the bond. Each of the atoms involved gives equal number of electrons to be shared. On sharing the electrons, the atoms attain stable electronic configuration or electronic structure of a noble gas. After sharing electrons, the atoms, each one of them, if you had to count its number of electrons, it should be the maximum. So it should be the number of electrons in the outermost energy level of an inert gas. The compounds formed are called covalent compounds. Now, the mistake that is commonly committed by you students is on spelling. The spelling is covalent. The spelling is covalent. So covalent bonds may be classified as single, they can be double bonds, they can be triple bonds, they can be quadruple bonds, depending on the number of electrons being shared. So one bond is formed by 2 electrons. If you have 4 electrons being shared, then there will be 2 bonds. If you have 2 electrons being shared, then there will be 1 what? Bond. So the first example we are going to look at is single covalent bond. Atoms that form a single covalent bond. Now we are saying single covalent bond is formed when one pair of electrons is shared. It is formed when one pair of electrons is shared. Each of the atoms involved contribute an electron to the bond formation. That one we had already talked about it. Each of the atoms formed contribute an electron to the bond formation. For example, we have a hydrogen molecule. Hydrogen molecule, it is a molecule that is formed, that contains 2 hydrogen atoms. So in this case, we are referring to hydrogen as a gas. So hydrogen molecule, we have hydrogen, and it has, its atomic number is 1, so it has only 1 electron in the outermost shell, as you can see. So 2 hydrogen atoms to form a hydrogen molecule, each one of them having an electron. Each of these 2 is going to contribute an electron towards the formation of a bond. So you can see the first electron is from the first hydrogen atom, and the second electron is also from the second hydrogen atom. And these 2 electrons that have been shared are the ones that form this bond between the hydrogen atoms. So if you are to count now the number of electrons for each hydrogen atom is going to have two electrons. And there is an inert gas which has 2 electrons, because remember, the first shell takes a maximum of 2 electrons. So that shell that takes a maximum of 2 electrons, the inert gas that has 2 electrons in the outermost shell is helium. The inert gas there is helium. So this is a hydrogen molecule, whereby each hydrogen atom has contributed an electron to the formation of the bond. Water molecule. Now, water molecule is going to be formed between hydrogen atoms and oxygen atoms. We first write the electronic configuration of oxygen. It is 2 to 6. If we are using only the outermost electrons, then it is 2 to what? It is only, there are only 6 electrons in the outermost shell. But what is the maximum number of electrons? It is 8. It is 8, which means oxygen needs 8 electrons to have a stable electronic configuration. So the other 2 electrons that are not paired, they are going to pair with the other electron from hydrogen. So the other electron from hydrogen comes with 1 electron, and it puts it where there is 1 electron of oxygen, and then the other one also comes with 1 electron, and that 1 electron is going to be shared with the other 1 electron of oxygen. So each atom contributes 1 electron to the formation of the bond, such that when you count the number of electrons in the outermost shell again, oxygen is going to have 8. Try to count them and see. They are going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And for hydrogen, it is now going to have 2, which is the electronic structure of helium, which is also an inert gas. So that's how a water molecule is formed. If you are looking for a compound between oxygen and hydrogen, then it means the hydrogen atoms must be 2, because oxygen has to share 2 electrons for it to have 8, which is the maximum. We look at a compound of ammonia. Ammonia is formed between nitrogen and hydrogen. For you, the first thing you do is draw the electronic configuration of nitrogen. That means nitrogen has 5 electrons in the outermost what? Outermost shell. So it requires other 3 to have 8. So the other 3 should come from hydrogen sharing, such that each hydrogen atom with 1 electron comes, and that 1 electron will be shared with 1 of oxygen. Then the other hydrogen also comes with its electron to share it with the 1 for oxygen, and finally the other one also brings its electron here, such that when you count again, you are going to have 8 for oxygen, and each hydrogen will bring 1, 1, and finally the structure will be N is nitrogen, and it has been bonded with 3 hydrogen atoms. That's why you are seeing the structure being made like this. So where you see a bond between nitrogen and hydrogen, there are 2 electrons being shared, whereby each atom has contributed 1 electron. I want someone to tell me how a compound can be formed between carbon and hydrogen. Who has an idea? Carbon and hydrogen. First, write there the electronic configuration of carbon is 2 to 4, meaning carbon has 4 electrons in the outermost shell, whereas hydrogen has 1 in the outermost shell. So who can tell me how a compound will be formed between carbon and hydrogen? I expected you to be doing something there. Hmm? So carbon, its electronic configuration is there. I mean electronic structure. Carbon has 4 electrons in the outermost shell. So for it to have 8 or to become stable, it needs to bond 4 times. Wherever there is an electron of carbon, I told you when you are filling the electrons, start with north, south, east, west, such that now the hydrogen atoms surround the carbon. So where there is a carbon, where there is an electron, a hydrogen atom is going to contribute its electron for bonding. So the hydrogen atoms must be 4. Because carbon needs 4 electrons to be what? To have 8 in the outermost shell. So that's what we end up with. On each electron of carbon in the outermost shell, there will be a bond of hydrogen. And that's how our thing comes up like that. So